Hey everyone, welcome to Coding Simplified channel, and in this video we'll see that how we can create the linked list. So basically though we have already linked list creation video, but I created this video so that we can also cover the iterative manner as well, because in our original video we have covered using the recursion, and I got feedback in some of the comments that I should also create the video that how we can create the linked list in iterative manner, and that's why we have this video. So basically in this video we'll cover the creation of the linked list. So at the last our aim is to create the linked list like this. So we'll be using the iterative manner here in this video to create the linked list, and we'll be using the Java language for creating this one. So when we'll do code, I'll also show you the code and everything via Eclipse, that how we can basically implement or how we can create the linked list via this one, right? So this will what we'll cover in the linked list. Before that, if you are coming here first time, so let me just explain you about the linked list. So linked list, it says a linked list is a linear collection of data elements whose order is not given by their physical placement of memory, right? So here what we do in linked list here kind of says that each element is kind of defined by next, right? So that is why each node has two values. One is the original value and the other one is next, and via next we are pointing to the next value. So that's why you can see here instead each element points to the next variable, right? So this is why you can see each points next to the next variable. It is a data structure consisting of a collection of nodes whose together represent a sequence, right? So basically why it is calling sequence, because each node, basically this we call as a node. You will hear the term node a lot because we call as a node, and a node can contains like two values. Right now you can see a linked list whose nodes contain two fields, an integer value and a link to the next node, right? So this is what we do. So the you see the 12 next point is pointing to the next node, the next of this one is pointing to the next node, and this one is pointing to the null, because this is the last element of the linked list, so it will point to the null, right? So basically you can again read little bit. Each node contains data and a reference, right? Now this data is integer. This data can be string, this data can be object, this data can be anything. But to make it simplify, currently this data is the integer and the next is a next pointer, right? So now what's the benefit we have our linked list to the array, right? So the biggest advantage that we have is this structure allows for efficient insertion and removal of element from any position in sequence during the iteration, right? And that's a major difference if we compare it with the array. In array what happens, that let's say I have this array. Now in array I have three elements, 12, 99 and 37. And if I want to add the array, if I want to add the element at second position, then I have to first shift the 37, 90, 99, then only I can insert the value. But in linked list it's very easy. In linked list you have to just go till the previous position and then you have to create the new node and that insert here, right? So that's what the advantage of linked list we have in with compared to array. So you can read from here as well. The principal benefit of linked list over a conventional array is that list element can be easily inserted and removed without reallocation or reorganization of the entire structure, because data items need not to be stored contiguously, right? Here we are not adding the contiguously. Wherever you want you can add. You can add here, you can add at front, you can add at last, and that's it, right? So it says we are not storing the contiguously, while restructuring an array at runtime is a much more expensive operation, right? So linked list allow insertion and removal of nodes at any point in the list, and allowing doing so with a constant number of operation by keeping the link previous to the link being added or removed in the during the list traversal, right? So that's what the biggest advantage that we have linked list, and that's why we use a linked list over array, because interviewer can ask that, hey, what's the difference between array and linked list, like why you would want to use a linked list rather than array. So this is a difference. In array the removal and the deletion operations are expensive, right? Because we have to shift the values. If I am removing, again I have to shift the values in array. but in linked list it is not the case. In linked list we don't have to shift. It's just that wherever I want I can add the element, right? So when you will see the all the programs like insert element at the front, insert element at the position, at the end, deletion from the any given position, from the starting, from the end, then you will figure out then how effective it is, like inserting and the removal element in the linked list, right? So this was a little bit description about the linked list, and now let me show you. Let's start the first part, which is about explaining that how we can create the linked list. So before that, let me show you what we have discussed here. So if you see that here we have, this is our class node. So like what we are saying, that here each node present, basically here we have nodes, right? In node, one value will have the integer and another value we have the next pointer, right? And we are calling as a node. So here you can see in Java we have one class which is node class, and node class represent the value. So basically I can say in fact data as well. So this is data, and here I need to also change. So what I'm saying, that here each node contains the data and the next pointer, right? And you see next is also a kind of the same node, because this is also pointing to the node, and that is why it will basically have the node value, right? So each node present a kind of complete block, so that is why we have this node, and currently it is containing the integer and a node. Later someone can ask you, linked list can have a string as well. Yes, it can have a string as well, it can have anything, right? But because we are making it simplify, so currently we have this integer and it is pointing to the next node, so it is kind of a link. So that is why we have this link, right? So this is the main structure that we have. Now let's see that how we can create the linked list, right? So at the starting, let's say this is my aim, I have to create all this one, right? So why, if my aim is this part, if my aim is this, so at the starting my linked list is null, right? So can I say that I have this head and this head is pointing to null, right? So at the starting my linked list is null. Now, so if my linked list is null at the starting, just add the first node, right? So it means here I will add the first node as 12 and null, and again my head is pointing to here, first point. Now once we have added first element, I want to add the second element. So what we'll do, the idea is that you start from the head and you go till the end, and then you add the element. So basically here the 12 and then we have the 7. So here, because here we have reached till the end, so here add the new element. So now here we have 7, and which is pointing to next null. The last pointer will always point to null, right? Again my head is here, because head will always point to the head node. Now let's say if I want to add. So again the logic is, just remember the logic, we have to go till the end and then add the element, because right now when I am creating the linked list, my aim is to add the element at the end. So here again I'll start from the head, then I'll move to this point, then again, because here the next pointer is null, so here I'll create a new node and I will add here. So again 12, 7, and then here I will add the 8 and then new null, right? Head will again point to the starting pointer. So basically what we are doing, we are iterating from starting, we are going till the end, and whenever the head, the node of next is null, because wherever the node of next will be null, at this moment we can add our element, right? So what we do, basically if you see, let's say if this is my insert function, right? Insert function, I will always pass the head node. So let's say if my head node, and here I'm taking as a node, and here I will pass the value, which is my value, right? Now let's say if my node is null, if my node is null means this will be the first case when my head will be null. So if my node is null, at this point I will say return get new node function. I can create a function get new node, and where basically it will give me a node. So what is node? Each node presents each node presents the integer and next pointer, right? If you see here, this is what is happening. In this case 12 and next pointer, this is what we are doing. So we'll basically create a new node and then we'll return if node is null, because if head is null we can return this one. But if it is not the case, then we have to go till the end. How we can go till the end? We can go till the end if node of next is not null. If node of next is not null, in this case just move node equals to node of next, right? And wherever node of next is null, it means we have reached till the end. So whenever you have reached till the end, now at this moment you can add node of next equals to get new node, because here you can add get new node and here you can pass the value which you are passing from there, and then what you should return. This is again a point, because let's say, because node is iterating, so let's say if I start from here, node will go here, then node will reach here, then at this point at the last node is till the last. So it means we have to basically store the starting value always, right? So that is why take the variable here node, and this will be first node equals to node, right? So this is what we are doing. So if you see what we have done here, this will cover the first case. This will cover the first case when my head is null. This will add the first node. If node is null, then return get new node. This thing will basically store the first value always in the first node, so that whenever we want we can return the first node, right? So this is how we can return the first node. And this thing, what it will do via this, basically will move to the next position from here to here, this while node, right? This will basically reach us to the last node. Like if we are here and let's say I want to add 15, so what it will do, will start from here, the node will be at the starting here, head will always point, this will the first node will point to here, node. Now the node of next is not null, so okay, let's see this 15 adding, right? This node add is so what it will do, again node is here, will move to next position, move to the here. Now node of next is null, so in this case we'll come here, and here we'll add basically node of next equal to new node, which will be 15. So here we'll add new node 15 and then will be null, right? And then at the last we can return first node, right? So that's what the concept we are doing here. So let's see one by one that how we can do and how we are basically how we'll solve this thing, and let's operate this part in this function, right? And then we'll basically know how it is happening. So let me start via this one. Yeah, so at the starting this is our first. So first of all we are adding 12. Now at the 12, because this is head will be null, so in this it will return get new node. So new node means it will basically we have a new function get new node. What it does, it just create a node function and that insert the value, right? So let me show you directly here so that you know. In get new node, this is what we are doing. We are creating a object of node. So here we have this node int data and next, right? That's what we have shown. And then we have this we are adding the value in data variable, that whatever value we have. So let's say if you have 12 at the starting 12, and the next pointer will be null, and then we are returning new node, right? So here what it will do, it will basically return the new node, so which will be 12 in this case, right? So it means we have first new node 12 and null. Next we are adding 7. So when we are adding 7, in this case the node is not null, right? Because we have 12 now. So it means the first node will be, it will store node, so it means this will be our first node, which will be 12. Now our node is also pointing to 12. So now see, if node of next is null, so yes, here this node is null, the node of next is null, so it means go out of the loop and add node of next equal to new node. So it means now it will add 12 and new node is 7, and which will point to null, right? Now let's say if we, and here we'll return first node, so it means it is always returning the first node, the head node. Now let's say if I want to add 8, so in this case what it will happen, again I will pass the root node which is 12, Now whether 12 is null, this is not null. So in this case we'll add the first node as this one. So again the first node will point to this one and node is pointing to 12. Now check operate this one, whether node of next is null, node of next is not null. So again move node equal to node of next. So now node equal to node of next, which is 7, right? Because this is node equal to node of next. So this is node of next. Now we have 7. Here the node of next is null now. So it means if node of next is null, so here we'll go out of the loop, while loop, and here we'll add node of next equal to get new node. So here we can add 12, 7 and 8, and at the last we'll return the first node. First node is still at 12, right? So this is how basically we can basically create or insert the element one by one, right? So let me show you directly via code as well, so that you know and you get confidence how it is happening. So what we have shown, we have shown that we have the node class which represents the data and which represents the next pointer. In linked list we have created 3 functions: get new node, insert and print list. So insert is the main function, how we are inserting the, or how we are creating the linked list, or how we are adding the values. So let's start from the main function. Here we have the main function, right? And so this is our main class basically. Here we have the helper class, and this is also a helper class. So now here let's see via debug mode one by one, so that you also see how it is happening. So this will just create the object first. So it will basically create the object, and that's it. Here our head is null, so at the starting our linked list will be null, right? Now here we are adding the first element. So let's see how it is adding. At the starting the node is null, right? So if node is null, in this case go to this function, it will create an object, add the value, next is null, and then it will return new node. So here if node is null, because this is we are adding first element, so in this case we'll just return, and our head is what? Our head is 12. Now we are adding the second element. In second element now our head is not null, right? Because now we have 12. So it will go ahead and we are storing the first node. So first node will be the starting node of the linked list. Now we are checking if node of next is not null, then move to this one. But right now the node of next is null, right? So in this case it will go here, and in node of next, in 12 of next, it will add the new node, because here again it will create a new node. So it has created a new node and it has added into this 12. So you can see here this is added new node, and what is new node? 7, because this is what we added, right? And then it will return the first node. If you see, first node is still at 12. So this is what happened. So it will go ahead, and that's it. Now let's say add. So when we'll add this 8 in this, now what the node we have? Node we have is 12, then 7. So basically our node is at head node. This is our head node at the starting, and node is not null. So it will go ahead, and the first node will take as a starting node, head node, so that we always return the first node. Here the node of, we check if node of next is null. Now here node of next is not null, because here the node of next is 7. So that's why it will go inside this one, and it will again go here. Now our node is 7. So now node of next is null. So it will go ahead and it will add the new node into next of this 7. So here it will create a new node, it will return the first node, and that's it, right? So this is how basically we'll add a node. Let's say if I have to add some more node as well, one new node as well. So let me show this one as well, 10. So let's say we have already covered till here, so I'll start from now here. So we have already seen 8. Now let's see the 10. So again this is starting node, it will have the starting node. Now node of next is not null, it will go ahead. Again node of next is not null, it will again go. Now here we have a node of next is null. So here it will add the new node and will return the first node. So now in head we have that first node, always head node, 12, 7, 8 and 10, right? Now let's say if I want to print the list. So if you want to print the list, so again that's something we can do. Let's say if node is null, then need not to print anything, but if is not null, so in this case print the value of node. So at the starting we have 12, so it will print the value and it will go ahead. Similarly, then if it is not null, then again we'll print the value. Again node is not null, we print the value. Again node is not null, so now we print the value, and at the last, because now node is null, So you can see, so in this case it will go exit out of the loop, and that's it, right? So this is how you can see that these are the elements that we have added. We added 12, 7, 8 and 10, and these are in linear mode, because whenever we add, we are adding the end of the linked list, right? So that's why it is adding at the last, and this is linked list we have, right? So this is how, guys, we have seen that how we can, add the linked list. And if you talk about the time complexity in this case, so what we are doing, whenever you want to add the items at the last, because here in creating linked list right now we are adding always element at the last, so we have to traverse till the end. So whenever we are adding a list, whenever we are adding element, we have to always go till the end, and that's where we are adding. So the same thing we have to do whenever to insert any element, we have to traverse an element, so it means our complexity is big of n, right? That's what we have to do, because we are traversing an element whenever we are adding a new element to go till the end. Now the space complexity wise, as such, we are not using any extra space, because it's just that we are creating a node, so that is explicit, because if we are creating a node, definitely we have to create a node, but space wise we are not taking any extra complexity, right? So space complexity wise it will be big of 1. So that's all about the space complexities and time complexities. So that's all, guys, about this video. We have seen that how we can create the linked list, or we can insert the element in the linked list at the end, and this we did via iterative manner, and hope you have liked the video. If you have liked the video, then please like it, and please subscribe to our channel. And guys, I will also post the code of this one in our description, so you can take the code from here. Thank you, guys.